Hello there, I'm Engineer Jed. Today, we're gonna learn about the engineer's transit, and that's gonna be our fieldwork number 2. The engineer's transit is an integrated instrument commonly used for surveying. It is capable of measuring horizontal angles, vertical angles, bearing. It can measure vertical distance, and it can also measure horizontal distance without even using a measuring tape. The engineer's transit is composed of three main parts. From here up to here, that is the upper plate. From here up to here, that is the lower plate. And then from here down, that is the leveling head assembly. We have the telescope. It is used to view objects which is a distance apart. At the upper part of the telescope, which is here, this is what we call the telescope level tube. As you can see, we have here a bubble. Once the bubble is centered, you can be sure that your telescope is in a horizontal position. So that is the function of a telescope level tube. Next is the lens. We have here the lens. Adjacent to the lens is what we call the lens hood. What is the function of a lens hood? Sometimes when we have our survey, the weather is not good and it's raining. So we have to protect our lens. So in able to protect our lens, we have to install our lens hood, and then voila. So if the weather is fair, of course you don't need this. So you have to reattach the lens hood just like this. Okay? The other end is the eyepiece. That is where you have to view your object. And then at the eyepiece, you have here the rotating knob. The rotating knob is used for the visibility of the crosshair. And here, at the right side of the telescope, we have three parts. We have here the focusing screw. Of course, from the term itself, focusing screw. Focus, that means this is used to focus your sighted object. And then we have here the telescope clamp. This is the telescope clamp. Okay, the telescope clamp, the function is to lock and unlock the movement of the telescope vertically. So after locking that one, we have here the telescope tangent screw. The function for this is to make your movement for the telescope in a slow motion. As you can see, the movement of the telescope is in a slow motion vertically. But this telescope tangent screw is not functional if your telescope clamp is not in lock position. At the left side, we have here the vertical circle. Inside the vertical circle is the vertical scale. As you can see, we have calibrations in degrees there. And at the lower part of the vertical scale is the vertical vernier. Vertical verniers are used to increase your measurement to a higher degree of accuracy. We have the standards. The standards are four posts of the upper plate that supports the telescope. And in connection with the standards is the horizontal circle. At the horizontal circle, we have the compass box. So a compass is used to determine the bearing or the angle of a line from a reference meridian. Here we have the plate level tubes. As you can see, we have here a bubble. Once the bubble is centered, then that means your horizontal circle is in a horizontal position. Right here, inside the horizontal circle is a horizontal scale. As you can see, horizontal scales are in degrees. And right beside the horizontal scale is the horizontal vernier. The same function with the vertical vernier. The function for it is to increase your measurement to a higher degree of accuracy. Right here, we have the upper clamp. The function for this is to unlock the movement of the upper plate or the horizontal plate. And right beside the upper clamp is the upper tangent screw. The same function with telescope tangent screw. It is used to move your upper plate in a slow motion. So that composed of the upper plate. Now let's move on to the lower plate. Right here, we have the lower clamp because it is in the lower plate. And right opposite of the lower clamp is the lower tangent screw. Again, the purpose for this is to make your movement of the transit in a slow motion horizontally, like that one. So these three screws are what we call the leveling screws. This one. And then we have the foot plate. So those are the important parts of a engineer's transit. Before we can do survey fieldworks, we have to know how to operate and know the different parts of a engineer's transit. Next, we have to learn how to set up and level the engineer's transit. Now, you have learned how to set up and level the transit, and you have learned the several parts of your transit. Then, you are now ready to perform surveying fieldworks using the transit.
Bawat bata may tanong,
Ba't ganito? Ba't ganon?
hayaang buksan ang isipan.
Sa science o agha